This is a video on how to determine the wavelength of an electromagnetic wave. We're going to start with this problem. What is the wavelength of a 1.5051 times 10 to the 8th hertz radio wave? So we're going to start with our formula. Our formula is lambda, which kind of looks like an upside down y, is equal to c over f. C stands for the speed of an electromagnetic wave in a vacuum, whereas F represents the frequency of the wave, and lambda is the wavelength. So, C in all of our problems that we're going to be doing is the constant 3.00 times 10 to the 8th, and our units are meters per second. You are going to use this in every single problem, figuring out our wavelength. So, in our problem, we're going to have C on top and frequency on the bottom. So our C is going to be 3.00 times 10 to the 8th meters per second. Now our frequency, our units for frequency right here are hertz. But another way you can see hertz is 1 over s, units wise. So it'll look something like this. 1.051 times 10 to the 8th, 1 over s. Now when you do that math, s is canceled out, and so you're just left with meters for our answer. But you can continue going with the hertz here on the side if you would like. This is just explaining the units and why we'll get meters at the end. So after you do all those calculations, in your calculator you're going to want to put in parentheses. You're going to plug in 3.00 times 10 to the 8th divided by, parentheses again, 1.051 times 10 to the 8th. Make sure you put the parentheses here or else you will get a completely different answer and the wrong one at that. So once we do our math, our answer is going to be 2.8544 something, etc. We are going to round to the nearest hundredth because some of our answers we're going to put in scientific notation. Scientific notation, like you see here, is to the hundredth spot. So we're going to round all of our problems to the hundredth. So with our rounding, we will get 2.85 because this 4 is less than a 5. And our units are in meters. As we can see, this is all that was left in our units up here. All right, here's our answer. Let's go ahead and look at another problem. All right. What is the wavelength of a 7.22 times 10 to the 8th hertz microwave? So we're going to start out with our formula. Lambda is equal to the speed of an electromagnetic wave over the frequency. And we're looking for the wavelength, which is lambda. All right, so our C is always going to be the same. It will be 3.00 times 10 to the 8th meters per second. That's always going to be on top. Now on bottom, we're going to use this. This is our frequency in hertz. 7.22 times 10 to the 8th. And again, for our units hertz, hertz is the same as 1 over s. You can write this or you can just write hertz, as long as you understand that these seconds cancel out and you are just left with meters. Okay? After you work that out, you are going to get 0.415 meters. But then again, we're going to round to our nearest hundredth. So we'll get 0.42 meters. Let's do another problem. What is the wavelength of a 3.00 times 10 to the 18th hertz microwave? We're going to start with our formula like we do. We're going to start with our lambda, which is the wavelength is equal to speed of the electromagnetic wave over the frequency. So we've got our speed, which is our constant, 3.00 times 10 to the 8th meters per second over our frequency. And in this problem, our frequency is right here. 3.00 times 10 to the 18th power and hertz, or if you would rather, 1 over a second. Those seconds cancel out and you will just be left with these. Okay? After we multiply that together, this problem we're going to put in scientific notation. You will get, on your calculator, you'll probably see something like 1e negative 10, and then you're going to add your units. This is the exact same as 1 times 10 to the negative 10th meters, and the exact same as 1.00 times 10 to the negative 10th meters. For scientific notation, this is the correct way to write it. This is still correct because in your computer, E is just times 10. Either one of these is correct. All right, let's do one more problem. What is the wavelength of an 8.12 times 10 to the 8th power microwave? And again, this is in hertz. What you're going to do first, you're going to do your formula. So you've got lambda is equal to the speed over frequency. The speed is always the same. 3.00 times 10 to the 8th meters per second. You're going to divide that by our frequency. Well, here's our frequency. 8.12 times 10 to the 8th hertz, or 1 over s. Seconds are going to cancel out, and you're just going to be left with meters. Now again, your calculator, if you just plug this in, all of it's going to go in that exponent area, so you do need your parentheses. So be sure to plug in with your parentheses. 3.00 times 10 to the 8th parentheses divided by parentheses 8.12 times 10 to the 8th. This will get you your correct answer, which should look like 0.37 meters.